So, hello, good morning, everyone. So, thank you very much indeed for, first of all, for your interest in this presentation, and thank you, of course, to the European Commission for their kind invitation to participate in this most interesting meeting on excellence in translation. The purpose of our talk today is to present our research on the use of artificial intelligence for the assessment of intralingual live subtitles, and also, we will present NerdBuddy, which is an application for the manual, machine-aided, and fully automatic assessment of intralingual live subtitles. It in both the machine-aided and the fully automatic modes, Buddy uses artificial intelligence technology. Buddy was developed in 2023 by members of the GALMA research group within the framework of the Spanish Ministry of Education funded QualiSub project that is led by University of Vigo with the collaboration of University of Jaume I, the University of the Basque Country, and the Spanish public broadcaster TV. And the aim of this project is to assess the quality of different intralingual live subtitling methods in Spain, in the UK, Canada, and the US. So, QualiSub also includes, by the way, a collaboration with the European Parliament. Well, artificial intelligence for language processing is being used these days for things such as this. Drafting texts or making summaries of text and things like that, or producing sometimes some more original expressions. And this could be a good example of that. We asked artificial intelligence, we are the user, tell me a joke about translators and artificial intelligence. And the answer by artificial intelligence was this, the assistant that you can see on the slide. Why don't AI translators play hide and seek? Because they always take things literally and can't understand the concept of hidden meaning. Well, perhaps the joke was not too funny, I must admit, but at least it is truly relevant as it touches one of the crucial issues that will be dealt with somehow in this talk, which is deep or hidden meaning versus verbatim repetition. But beyond this, artificial intelligence can be used these days for things such as this, for the assessment of language services provided to minority groups. Um, this is an explanation about accessibility and particularly about inter and intralingual live subtitling, which is one form of media accessibility where access is provided by means of live subtitles that are shown on the screen. If the subtitles are in the same language, the activity is called intralingual live subtitling. If they are in a different language, it is interlingual live subtitling. Intra and interlingual subtitles have traditionally been used as an accessibility service for deaf and hard of hearing people in intralingual, I beg your pardon, without translation, in intralingual live subtitling. A live TV broadcast or event is subtitled in the same language as the original. Therefore, there is no translation. And for those of you, for those in the audience who may perhaps be wondering why this talk is part of an international conference on translation, just two ideas. First, intralingual text production without translation is not just the mere repetition of words. In intralingual live subtitling strategies, which involve the full processing of deep meaning, very much in tune with the basic principles of translation and, above all, of simultaneous interpreting, are applied. For example, condensation strategies. But also, live subtitlers have to edit the text. They have to add punctuation marks, they have to add color tags to identify speakers, and they have to remove unnecessary elements from the text, such as hesitations, fillers, and things like that. Therefore, intralingual live subtitling has to be seen as a process that is akin to translation and therefore relevant for this meeting. And also, another point that is equally important is that live subtitles, intralingual live subtitles, are being increasingly used by hearing people, for example, by the elderly who have hearing problems, but also by the population at large when they are when screens are placed in large public spaces, commercial areas, restaurants. In those opportunities where turning on the volume is not a choice, in fact, it has been estimated that as many as 40% of all Americans make a regular use of captions, although only 7% of them have hearing problems. So, intralingual live subtitling and interlingual as well is subject to major changes, rapid changes stemming from breakthroughs in technology, and can be provided a by means of a number of different workflows, which may be divided into three groups. As you can see on this slide, one is based on the use of keyboards, um, from traditional keyboards to a specialized instrument such as the velotype or stenotype. One that is based on re-speaking or speech-to-text interpreting. Well, re-speaking is a captioning system where an expert trained for the job receives an oral input and produces another oral output, but that output will not reach the audience directly, but rather it will be dictated to an automatic speech recognition engine, ASR, that will automatically produce the captions on the screen. Respeaking can be intralingual and interlingual, just like um, intra and interlingual live subtitling. And when it is interlingual, with translation from one language to another language, the process is, cognitively speaking, very similar to that of simultaneous interpreting. By the way, this is our course on interlingual re-speaking or speech-to-text interpreting at the University of Vigo between English and Spanish. And as I say, it is a process that is very similar to that of simultaneous interpreting. But the point is that there was another phase, such as I was saying, where that is based on the use of automatic speech recognition, ASR. Let's now look for a minute at the efficiency of the different workflows for intralingual live subtitling, because what this slide shows is that the different ILS methods present certain advantages and certain disadvantages. This is, by the way, a research by my colleague Romero Fresco from 2010, and he found this. So the point is that different subtitles produce different levels of efficiency in different areas. But also, we are aware that the different types of subtitles or systems used for the production of subtitles produce different types of captions. We know, for example, that captions produced with automatic speech recognition and keyboards are more verbatim than those from Respeaking. Not in vain, both ASR and keyboards were developed with that goal in mind. However, intralingual re-speakers are trained, such as I said before, following the principles of simultaneous interpreting, and therefore their subtitles are not verbatim or not as verbatim as those from ASR or keyboards. However, ASR was not truly disruptive until the arrival of artificial intelligence support. Before this, ASR made abundant and gross mistakes. The captions were very often incorrect or plainly senseless. So two of my colleagues from Galma and Qualisub, Romero Fresco and Fresno, set out to explore recent improvements in ASR technology by comparing 2021 ASR software with other products that were launched in 2023 that take advantage of artificial intelligence technology. And as you can see, the 2021 non-AI, non-artificial intelligence ASR software did not reach the minimum levels of accuracy required by NERD, which is 98%. By the way, NERD is the instrument of analysis that we are using for the evaluation of captions. I will explain to you in a minute what NERD actually is. And as you can see on the left-hand column, the 2021 ASR software did not reach the 98% accuracy established by NERD in 3 out of the 4 samples analyzed. Whereas if you look at the other 2 columns, 2023 AI-based ASR, what we observe there is that this shows extraordinary, even unexpected levels of accuracy, always above 99%. 99% is a more than remarkable performance beyond the values that we normally find in the analysis of other NERD samples. But as I said, you might be wondering, what is NERD? Well, this is not NERD. As you can see, this is WORD. This is the word model, because the word model was the method that was originally designed for subtitle assessment. And the problem with this model is that it rests exclusively on word count. That is to say, it does not account for instances where a subtitler edits the original text without necessarily changing or losing meaning. And this can be observed in this slide here, where the subtitles to the right omit important asides or fillers from the transcript to the left. Things like, for example, I mean, kind of, and noises which involve no loss of meaning at all. However, the word model, by the way, word stands for word error rate. The word value for that subtitle would be 52% of errors. 52% of errors. The main advantage of Word is that it is very simple to apply because it rests exclusively on word count, and that is probably its main advantage. Well, the NERD model was developed later on by Romero Fresco in 2011 to fill precisely that gap, because this model looks at meaning. It looks at the amount of information conveyed and not at the number of words in source text and target text. Um, uh, there are different degrees of severity for the errors. They may be classified according to this model as serious, standard, or minor. And according to the principles of NERD, a 98% target or efficiency is required as the minimum quality threshold. So the thing is that with the NERD model, this subtitle, don't forget, it was 52% errors according to Word, would have been graded with 100% NERD accuracy, 100% accuracy, which is precisely what it is, according to the principles of translation and interpreting, where we don't want to have noise, we want to have information. However, the problem with NERD is that it is time consuming and demands very careful analysis between source and target text differences. And that is probably its main limitation. And that is the point where making it automatic with the support of artificial intelligence appears to be worth the effort. So what follows will focus on the work of GALMA group members in the development of an application for ILS assessment following the principles of the NERD methodology. And this is precisely NerdParty, the application developed by this group. The main features of NerdParty are this that you can see on this slide. It is first of all meaning-based. As we have just said, we will use the nerd as the instrument that we employ to measure the accuracy of these subtitles. Also, its usability, it is user-friendly. In the third place, it includes 3 levels of automaticity, as said before. And finally, number 4, we intend to achieve maximum levels of accuracy, at least the 98% NER threshold. So I will not deal with the first idea. It is NER-based, it is meaning-based because it has just been explained. And I will go straight to user-friendliness, because the point here, this is the aspect of our application, the layout, and the method that had been used for application of NER in the past were based on the use of large Excel worksheets with an unlimited number of columns. And these documents are difficult to handle, even though certain improvements have been done because they could make the calculations automatically, which is something that couldn't be done in the past and had to be done manually as well. But still, those upgradings only saved a small fraction of the time required for analysis. So in our case, user friendliness was achieved, first of all, thanks to the clarity, the simplicity of the layout, with just 2 columns where you can host, you can upload the reference text and the subtitles. By the way, these columns can be shifted from left to right. And I will try to play this from here. First, the clips analyzed can be played from the time marks, and the columns can be shifted, such as I said, from left to right. And as you can see, we are watching the clips from where we have the transcript. Oh, sorry about this. I went to the wrong slide. So this is, you're seeing the process again. So the texts, reference text and subtitles are uploaded into the different columns, and once the texts have been pasted, they can be aligned according to different criteria. They can be aligned from the original or from the subtitles. Oh my God, this is not it. I'm having a problem with this. I will let it run. Uh, so this is it. And at this point, once we see this, we will see that the application will automatically highlight in gray, because we have a color code for this, all differences between referent text and subtitles, including words, but also including punctuation marks. This is it. We are seeing all differences, all textual differences between the text, and now they are prepared to be sent for automatic assessment, right? We can send all this for an automatic artificial intelligence assessment. We can proceed to a fully manual assessment, or we can do something in between the two. But prior to this, of course, extensive training by quality of members had to be done to adjust the language model to the specific features of NERD. So in the automatic mode, as you can see, the application will be highlighting textual differences of errors in different colors. We have the typical traffic light system with green for minor errors, yellow for standard, and red for serious errors. And the system will also work out the data according to the NERD formula all the time. Also, by, let's play this again, by clicking here. Oh my God, having problem with this. Sorry about that. I was saying that by clicking the body icon that is situated, once we have sent this for evaluation, by clicking the icon that is situated in the middle column, you can see the answer. Oh my God. You can have the answer from artificial intelligence. I think I will not stop the video because I'm having trouble with it. So by clicking the body icon in the middle column, you can see the answer from artificial intelligence shown in a box. In the semi-automatic mode, humans can now revise and change the errors and their severity by just clicking the pen-like button that is situated in the middle, so that you can drag the words to a different color, and the system will always be calculating the numbers, the percentages of NER automatically, by simply dragging the words to the corresponding boxes. Also, there is a system by means of which you can add notes and any comments that you consider relevant. Here we are changing the severity of the different errors. This is done, of course, manually. And at the end, you can have all the details. The details will be shown in two different formats. There is a blue ribbon that is situated on top with the more general details, and then you can show the 5 tables here where all the different details are included, the number of errors of all types, and so on and so forth. And the system will be working out automatically all those numbers all the time. So this is how this application actually works. But of course, the process of achieving high levels of accuracy with Buddy's automatic system was very complicated, because we always try to make its assessment comparable to human assessment. That is the most challenging part of the process. Language models are trained with huge amounts of information that is relevant for many different types of activities. Later on, human trainers can engage in a conversation with the system to provide instructions to the machine. We're not going to deal with the general training because that is done at the company's server. What is important for us is to talk about the specific instruction done by QualiSub members, which includes 2 potential kind of activities. One is prompting or prompt engineering, which is one kind of training, what we call guided instruction. And the other is the fine-tuning approach, which is basically based on self-learning or self-instruction. So since these 2 routes are different, our team decided to follow the 2 routes, the one based on guided instruction and the one based on self-instruction. And we, of course, obtained different results. So we shall look at the results from guided instruction in the first place. But this is just the preliminary tests because we fed the system with as many as 52 or 54 sets of prompts in 3 rounds of tests. The samples were sent for automatic artificial intelligence based assessment, and that automatic assessment was always compared to human assessment. That is the point. To human assessment by QualiSub members who are experts in the evaluation of captions in search of human-machine consistency. But also bearing in mind the 98% acceptability threshold as established by NER, which was not achieved at that point. Our best score was, as you can see, 96.89, which is not a very good score. But um, uh, so we decided to run another test. And here, a random sample taken from a mixture of different content types generated with various state-of-the-art AI-based ASR systems was sent for automatic assessment. The samples were just 17 minutes in Spanish and 15 minutes in English. And the results were all the more encouraging and are the ones that you can see here. We did this just because we observed that the automatic assessment was much more rigorous than human assessment. So the machine was identifying many more problems, even the slightest differences between texts, which is exactly what the machine had been instructed to do. And therefore, it was grading all of them as textual differences and therefore as errors. And so we thought that the low nerd levels that we were finding were probably the consequence of using subtitles produced by re-speakers. Subtitles from re-speaking are not verbatim. In fact, subtitles from re-speaking normally include a lot of editing with a word reduction rate of approximately 40%. Or it might also be the result of using old ASR systems, or it might be a combination of the two. And that is why we decided to run this test with last generation ASR. And our results, as you can see, were very encouraging. These are our best results from prompting after many rounds of tests. But let's not forget that this sample was very small and only included last generation AI, artificial intelligence. So we turned to self-instruction as well, because although we were making substantial headway with the prompt engineering approach, we decided to test self-instruction too. After all, we come from university and that is our job, learn more. And also, I believe that the ability of artificial intelligence to learn on its own is probably the most exciting aspect of artificial intelligence. So we instructed the test the model, I beg your pardon, with 2,000 examples of information. And as in previous tests, what we tested was human judgment as compared with the judgment of artificial intelligence. And these were our results. Again, all the more encouraging. The 98% NERD threshold was achieved in all samples, and the numbers were consistent with human assessment all through the tests. Although the NERD values after self-learning were not as high as after guided instruction, this is more than likely the result of the limited number of tests that we have run with this approach as compared to the 52 tests that we run with the other approach. But of course, we have to be very cautious with all these figures because this is, again, just a pilot test with a very small sample, and many more tests will be required to confirm this. Also, higher levels of performance by body in the automatic mode are to be expected from improvements in training and instructions. So on this slide here, you can see in this table all the results from guided instruction and all the results from self-instruction, and the sample sizes are measured differently in minutes because these were clips. When we talk about examples, it is because they are lines of examples. But the thing is that the 98% threshold was achieved in all the samples, which was quite good. Now, I'm not going to deal with the limitations of artificial intelligence-based systems. If you want to read this, this could be a good example of what has been called hallucinations by the models, which is a tendency to invent, to fabricate their own answers, and also the tendency to self corrections, which is quite visible on this slide. But I will go straight to our discussions. The limitations of artificial intelligence are well known, I think. But let's go for our discussion. Artificial intelligence for intralingual live subtitling assessment is very promising. In this research, we have tested artificial intelligence by comparing human assessment to automatic assessment, and we have achieved high levels of consistency between artificial intelligence and humans. And this was achieved with both the prompt engineering approach and also with the self-instruction mode, and both with ASR alone and with a mix of ASR and respoken subtitles. Also, we have always reached in our final test the 98% threshold, which is quite good. However, the levels achieved with subtitles mostly coming from cutting edge AI-based ASR. That was the majority of the sample, and therefore we need many more tests to confirm all these results. On the other hand, we believe that the benefits of our research are not constrained to the use of artificial intelligence, since we believe that the application as such can be very useful with all the advantages in terms of simplicity. In fact, we have been approached by companies in the sector who might be interested in testing this. Um, Also, we have expectation for the potential automatization of NTR, which is a model for speech-to-text interpreting or interlingual re-speaking and simultaneous interpreting. And the thing is that the complexity of language processing is very complicated. And at this point, we are asking the machine to do nothing less than making human like judgment, which is quite complicated. So that is a major challenge of artificial intelligence. Many more texts will needed. We believe that there is ample room for improvement. And finally, I would like to just take 30 seconds to acknowledge the work of my colleagues at QualiSub and Galma. This research has only been possible thanks to the joint effort of a group of experts in different areas: subtitling, caption assessment, computing, of course, simultaneous interpreting. And I think that the main strength of this research is precisely this. Thank you very much indeed for your attention. I think I have to stop here, so thanks so much. If there are any questions from the floor, I will be ready to try to answer them. Thank you.
Thank you, dear Luis. Could you please switch your camera off and on again? We lost your video at some
Oh my
point,
God.
but the slides were visible.
Were
So I didn't
they?
want to interrupt you.
Oh, so sorry.
Just the
Uh,
camera. Maybe it will come back
okay, but
because we
could you see the slides? That is the most
absolutely, yeah,
important thing. Oh,
yeah, yeah, yeah.
fantastic.
We could.
I am relieved.
Um, I don't. Well, I don't see your video still, but what I will
No,
do
no,
is I share the Slido code. So if anyone
please.
has a quick question, we have 2 minutes. You can ask your question there, and Luis will happily answer.
I'm still struggling with my camera, by the way.
Yeah, for some reason we don't see, or I at least don't see your video. It's black,
No, you're
but we
right.
hear you well, and the slides were visible, so that's the most important thing.
Fantastic. Thank you.
So, any questions, dear audience? We have a very very last minute. Ah, yeah. Do you see it? Who can use Nearbody? Were you thinking about TV channels or other clients?
Sorry, for some reason I cannot activate the camera, but I can answer the question. Yes, who can use NerdBuddy? Were you thinking about TV channels or other clients? Yes, definitely. We are thinking about TV channels fundamentally because they are the ones who are actually doing this. They are the ones who are, in some countries, they are obliged by law to monitor the quality of the subtitles they produce. And therefore, um, it is a requirement established by law in Canada and other places. And therefore, there are companies within the sector that are truly interested in this application and in the use of artificial intelligence for TV broadcasts. But of course, this could be applied to many other clients. I mean, as we have said, live captions are being used increasingly all over the world. Therefore, we see many opportunities for this software to have to be used directly by the public. Yes.
I'm afraid we are already at the end of the session, but Luis, can people send you a direct message on the platform if they have any
Please,
further questions?
please do so. Do so. Yes, of course you can. I forgot to show you my email address, but I think it will be on the program. Yes, I will be delighted to try to answer your questions. Thank you very much
Absolutely.
indeed for your attention, and thanks to the European Commission for this opportunity.
Thank you very much. And yes, your contact details are on the platform, so please reach out to Luis if you have any more questions that we can't answer now. The main session is now starting, and I wish you all a very good day today. Goodbye.
Bye bye. Thank you again.